Welcome to the Sophistic Online Documentation. This part of the tutorial demonstrates the use of the tracer option for footfall analysis, as well as results of the full excitation calculation with the influence radius option enabled. In the previous video, we reviewed the report results of the footfall analysis for the case of self-excitation, where node 1592 in the office area was identified as having the maximum response factor. We'll now examine in more detail how this value was obtained using the result tracing feature available within the footfall analysis task in Fairbench. To do this, we created an additional analysis using the same input parameters as the previous self-excitation case. The only change is that the node 1592 is defined as a response location and the tracing option has been activated. We will now calculate this analysis and check the generated report. It includes a new section called Result Tracing, which provides a transparent overview of the intermediate calculation steps. Both steady-state and transient analysis results are included, but we'll focus on tracing of the steady-state response as it was the decisive result. The maximum response table and the frequency spectrum plot for the selected node serve the same purpose as shown in the previous video. In addition, modal responses table gives detailed information on the filtered eigenmodes, including their frequencies, modal damping, generalized modal mass, and mode shape values at the selected response and excitation nodes, which are the same in the case of self-excitation. The harmonic loading section summarizes the calculated harmonic forces corresponding to the decisive walking frequency, based on the selected CCIP load model for floors. The final table, Harmonic Responses, presents the calculated real and imaginary components of the response for each harmonic and each eigenmode. From the summed contribution of all harmonics, the total acceleration response per harmonic is derived, from which the response factor is calculated. The final square root of the sum of square response factor matches exactly the value reported in the maximum response table. We can observe that the largest contribution to the response factor comes from the fourth harmonic, and specifically from the first eigenmode. This confirms the resonance behavior previously identified at 2.36 Hz walking frequency, since its fourth harmonic aligns with the first eigenmode frequency. In the final step of this tutorial, we will examine the results of the full excitation setup. The full excitation analysis evaluates the response of each node by considering all specified excitation locations, selecting the most unfavorable result. While this approach is computationally more demanding, it provides more conservative results and may lead to a smaller compliance area. To reduce computation time, Fairbench offers an additional option, full excitation with an influence radius. This means that only excitation nodes within the defined influence radius around each response node are considered during analysis. We have added a third analysis with the same setup as the self-excitation case. This time, however, we have specified excitation locations as quad groups 10 and 20, representing the hallway and office space respectively, and activated full excitation with a 5-meter influence radius. After running the calculation, we can review the report. For the office space, the maximum response from the steady-state analysis again occurs at node 1592, as in the self-excitation case. However, the compliance area has dropped from 86 to 79%. We can verify this visually using the interactive graphic task. Where the final graphics illustrates the comparison. The left image shows response factors from the full excitation analysis, while the middle and right images compare the non-compliant areas, marked in red, between the full excitation and self-excitation analysis, confirming the increase in non-compliance when using full excitation. Thank you for your attention.